Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to solve some of the problems based on the concept of centroid, and we are going to find out the centroid of various sections. Let us recapitulate some of the sessions what we have covered in the previous session, some of the problems. We covered in the previous session centroid of a symmetrical sections about vertical axis and symmetrical section of both vertical and horizontal axis. That means two lines of symmetry and single lines of symmetry problems are solved in the previous sessions of a I section and H section. And here in this session we are going to solve the problems of unsymmetrical sections. That means it is not symmetrical about any axis. How to crack these questions? By using the concept of the centroid. Now here there is L section is there. The L section is the section is such a way that it is neither symmetry about vertical axis nor horizontal axis. Now this I section is having a geometry of section 1 and section 2. L section is having a geometry of section 1 and section 2. Section 1 is having a geometry of 100 millimeters length, 20 millimeters thickness, and section 2 is having 80 minus 20, that's 60 millimeters length and 20 millimeters thickness. So this L section is neither symmetrical about horizontal nor vertical axis. So for such cases we have to find out both bar X and bar Y. Alright, so how to calculate the bar X? We are going to use the expression of A1 X1. Here there are two sections, so 2 times areas to X1 and X2s. A to X2 by the sum of A1 and A2. On the bar Y equal to A1 Y1 plus A2 Y2 by the sum of A1 and A2. Okay, what is A1? Area of the section 1. What is A2? Area of the section 2. What is X1? Here the reference axes are required in order to find out the X1 and X2 value, X1 and X2s. So X1 is the horizontal distance from vertical line, that is Y line, and Y is the vertical distance from the horizontal line, that is XX line, reference lines. So here, what is the G1 point of, what is the centroid point of section 1? In centroid point is, that is 20 millimeters by 2, the 20 by 2, 10 millimeters. And what about 100 millimeters? Off of this 100 millimeters, that is the G1. That means the distance here it is 50 millimeters. From here it is 5 millimeters. 20 by 2, 10 millimeters. Now similarly, from reference axis, this is the off of the distance 60 by 2. This from here to here 30 millimeters. Plus here it is 20. Now the distance from reference axis here is 20 plus 30, that is 50 mm. Then from reference axis, what about this point? This is again 10 millimeters. Now this 10 millimeters is X1. And what about this distance? This is X2 equal to 50. And this 50 millimeters is Y1 and this 10 millimeters is Y2. So here we know X1, X2, Y1, Y2s, X1, X2, X1, X2, and Y1, Y2s. What is required next? Area of section 1 and section 2. What is the area of the section 1? Area of the section 1, A1 equal to area of the section 1, the length is 100 millimeters, thickness is 20 millimeters. that is 2000 square millimeter. What about A2? The A2 is area of the section 2. Area of the section 2 means this is the portion that is 60 millimeters length, 20 millimeters thickness. So 6 to 12 and 620 is a 1200 square millimeter. Substitute this A1 and A2, X1, X2, Y1, Y2. What is the X1 values from here? X1 is 10 millimeters, X2 50 millimeters. What about Y1? The Y1 equal to 50 millimeters. Y2, what about Y2 is 10 millimeters. Now, what about X1? Substitute here. A1 is 2000 millimeters, X1 is 10, A2 is 1200, X2 is 50. And when A1 and A2 2000 plus 1200. What about bar Y? A1 2000, Y1 is 50, A2 1200, Y2 is 10 millimeters. Now, that's what we have done here. Coming to the procedure, again, procedure is that rectangle 1, A1 equal to 2000 square millimeter, X1 10, Y1 50. And rectangle 2, what about A2, 1200 millimeter, that's 80 minus 20, this is the portion, 60 into 20. And X2, what about X2 from here to here? That is, you cannot make it 80 by 2. No, it is 20 plus 60 by 2, 50 millimeters. What about Y2? From this point to vertical distance. These are reference axes we considered here. These are the reference axes. So that's why this is the distance, that is 10 millimeters. If you substitute, we'll get it. A1, X1 and A2, X2 and A1 plus A2. Then it is 25 millimeters X1 and bar X is 25 millimeters, bar Y is 35 millimeters. Now, for this case, the reference axis, these are the reference axis, alright. Where is the location? This is the 25 millimeters. Bar X is about 25 millimeters. It is approximately here 25 millimeters. Yes, 25 millimeters we consider, assume. Now, what about bar Y? The bar Y is 35 millimeters. Now, from here, this is the reference axis. Bar Y is 35. This is 20 plus 15. It is approximately, this is centroid. This is the G point. The centroid point of the section, L section centroid point. L section centroid point, where it is L section centroid point? It is not on the geometry. It is outside the geometry. Okay. There is a meaning here. So generally we have a conception of centroid should be on the body. Okay. But we have the way visual inspections and all. The centroid is outside the geometry for this L section. And centroid also, the location of the centroid can be on the geometry when, anybody? When it is symmetrical about either single line of symmetry or two lines of symmetry, then the centroid will be the location, the point of centroid will be on the geometry of the plane. Here it is the symmetrical about both horizontal and vertical axis is the intersection of two lines, that is the geometry, the centroid. It is for two lines of symmetry. For the two lines of symmetry, location of the centroid is very, very simple. Why? Just draw the vertical, the symmetrical about vertical axis and symmetry of the horizontal symmetrical line. The both vertical and horizontal intersection point, that point is known as the point of centroid of that particular plane. And one more thing, suppose if it is not symmetrical about both the axes, it is symmetrical about only single line. This is the geometry of the top flange, length of the top flange, and it is the length of the top flange, it is the geometry of the bottom flange, and it is the length, geometry of the top flange. And here it is the web. For this case study, It is not symmetrical about horizontal axis. It is symmetrical about one line of geometry, one line of symmetry. Single line of symmetry is symmetrical about vertical axis. For that case, where the location of the centroid will be on this symmetrical axis. So it is on the symmetrical axis, the length may be varying either above or below, we may be at the somewhere else. But the G will be, the centroid will be on that. The centroid will be where? On the geometry only. If it's for single line of symmetry or two lines of symmetry, the centroid, the point of centroid will be on the geometry. Okay, it is not necessary. Now that it is neither two lines of symmetry, unsymmetrical about both x and y axis are parallel, both horizontal and vertical axis, unsymmetrical sections, the geometry, the centroid point will be outside. It can be outside the geometry. All right. Here in this case, G, the centroid is on the geometry. For that L section, the point of centroid is outside the geometry. Okay, this is one of the property or characteristics of the point of centroid. Now coming to the next problem is so far we have covered simple figures joined, like a rectangle joined in different manner. The L section, the two rectangles are joined each other. And in the previous sessions, I section, the rectangle joined in different sections. And the channel section also we have studied in previous sessions. The channel section is having, the three rectangles. But suppose if here it is a rectangle and semicircle, parallelogram, semicircle and triangle is composite figures. For this type of things, how to find out the centroid for this type of planes? Generally, in practical real field applications, the centroid, the sections of the beams are either rectangle or L section, C sections, okay, and rectangle, hollow rectangular sections, and I sections are available or will be used in real field applications. The sections of the beam are solid rectangle. Okay, why we have to use such type of sections we'll study in the previous coming sessions. Okay, up to that we have to tell. Now here the thing here it is, we are going to find out the triangle is joined, but it is just a practice how to locate for such cases, how to find out the centroid. All right. So for such cases, again we have to go for the geometry, the expressions, the derived expressions of bar x and bar y. Why here it is symmetrical. It is symmetrical about any axis. Is this symmetrical about any axis? No. It is unsymmetrical geometry, unsymmetrical plane. It is symmetrical. It is neither symmetrical about vertical nor horizontal axis. This type of planes comes under the category of unsymmetrical sections. Okay. So how to find out such unsymmetrical sections? Again, we have to find out bar x and bar y. What is bar x and what is bar y? The bar x equal to how many sections are there? Section A1, A2, A3. There are three sections are there. Bar x equal to derived expression. What is the expression here? A1 x1 plus A2 x2 plus A3 x3 upon A1 plus A2 plus A3. And bar y equal to, what is the bar y? The bar y equal to A1 y1 plus A2 y2 plus A3 y3 by the sum of A1, A2 and A3. These are the three things. Alright. So which geometry we have to go to consider as a section 1 and section 2? Here the rectangular portion is considered as a section 1 and semicircular portion is considered as section 2 and the third one, triangle portion, is considered as section 3. So what is the reference axis from here? The reference axis or left portion is considered the reference axis and the bottom portion is always horizontal reference axis. Always consider the left side, the positive zone. We kept the plane in a positive coordinate. Both x and y are positive. Alright. Now these are the reference axis bar y and bar x. Now consider the rectangular portion A1, area of the rectangular portion, that is length and breadth. The product of length and breadth. What is the length? 100 millimeters. Breadth is 50 millimeters. 100 times 50, that is 5000 square millimeter. What about x1? X1 is the distance from, is the horizontal distance x1 from vertical axis, from vertical YY line to the centroid of individual element rectangle. This is G1. Whatever this portion becomes here 100 by 2, that this portion distance is 50 millimeters. Okay, 100 by 2. Then we want a distance from this position to this portion, that is x1. Whatever x1, that is 25 plus 50. That is 25 plus 50, 25 plus 100 by 2, that is 25 plus 50, that is 25 millimeters. Okay, what about y1? Y1 is the vertical distance. If you want to measure vertical distance, from which axis vertical distance is? From horizontal. The reference axis xx. From here to here, that is the y1. How it comes y1? That is 50 off of 50. That is 50 by 2. That is 25 millimeters. 25 millimeters x1 and y1. Okay. Now that is a rectangular portion is completed. Now whatever semicircular portion, coming to area of the semicircle A2 and again x2, y2. How to get it x2, y2? Come on. How to get it x2, y2? Now is the section 2. Now for the section 2, this is the section 2 portion semicircle. How to get x2, y2? This is the G point. Here it is G2. Alright. And this distance is x2 and this distance is y2. Here for semicircle, if you go for the fundamentals which was shown before, for semicircle x angle, that is 4r by 3 pi. Alright. How to get it here? Now what is the A2? A2 equal to pi d square by 4 by 2 or pi r square by 2. That is pi r square by 2, pi by 2 times what is the radius of the semicircle? The radius is 25 millimeter. Substitute in the place of the r is 25 millimeter. That is pi r square by 2 is 982 square millimeter. What about x2? X2 distance, here it is. We know that this height is 4r by 3 pi. Okay. This distance is 4r by 3 pi. How to get it this 4r by 3 pi? All of you. That means this distance we want. X2 is this is the distance. X2 is this is the distance. This portion we want x2. That means 25 minus, subtract this 4r by 3 pi from 25 millimeters. That's 25 minus 4r by 3 pi. Pay attention. Very simple. This is the portion, the centroid location for this semicircle. Alright. Whatever semicircle distance, this is the total, this is the central distance. Suppose this distance means what we want? Diameter by 2, that is distance. And whatever this distance is, that is 4r by 3 pi. But our reference axis here, this is the reference axis YY, vertical. If you turn it, no, this is the YY portion. For this is the reference axis. We want distance from this distance. We want this distance. We know this distance. Distance is 4r by 3 pi. This distance is 4r by 3 pi. That means 25 minus 4r by 3 pi. That is 14.4 millimeters. Okay, this distance 14.4 millimeters. Now y2 equal to, what is the y2 equal to? This is the distance of. That y2 distance means that is, this is 25 millimeters. What is distance? 50 by 2, 25 millimeters. So x2, y2, that is x2 is 14.4 millimeters, y2 is 50 by 2, that's 25. Pay attention, very careful, very simple. Semicircle is like that. Okay, this is the portion. This is 4r by 3 pi. And this is our reference axis is here. This is the reference axis. We want this distance, that is x2. We know the total distance, this is 25 millimeters. So if we want this portion, x2 portion, that means 25 minus total minus this, subtract this portion, that is 4r by 3 pi. Then what happened? x2 equal to 25 minus this portion, that is 4r by 3 pi. Then you will get x2 value. That x2 equal to 14.4 millimeters. 14.4 millimeters. And y2 equal to 25 millimeters. Alright. Now the third portion. So far we covered a rectangular portion, rectangular section and a semicircular section. Two sections are completed. Now the third section is the triangular portion. Third portion is, this is located here. Now whenever before going to locate here, we have to locate that centroidal distance, that is G3 here. Our reference axis here, these are the reference axis. The distance, horizontal distance from G3 to this portion is known as x3. From vertical distance G3 to our horizontal axis, that is y3, that is y3. That is x3 and y3. Alright. Now what about area? Area of the triangle A3 equal to of base into height. What is the base here? Of times. What is the base? This much portion. That is 25 and 25. That is 50 millimeters. And height, that is 50 millimeters. Of times 50 into 50. That is 1250. 1250 square millimeter. Okay, what about x3? We want x3. From where we have to get it? Okay. So here the x3 is considered. How to get it? x3 portion? Very important. Now we have to find out x3 is the sum of, okay, is the sum of, this is the line, the passing line, the section line. x3 is the sum of 25 millimeters, 50 millimeters and 25 millimeters. 25 plus 50 plus 25, that is 100 millimeters. x3 is the x here, centroidal. Okay. What about y3? y3 equal to, this is the y3 portion, total portion of the y3. How the y3 comes? From here to here, the distance y3. y3 is the sum of 50 plus h by 3. What is the h? Height 50 by 3. 50 plus 50 by 3. That is the from here to here 50. From this distance we want, that is h by 3. What is the h? 50. 50 by 3. Okay. So that is 50 plus 50 by 3, that is 66.7 millimeters. Okay. From this we know A1, A2, A3, X1, X2, X3, Y1, Y2, Y3, the values of those areas and the distance from reference axis are known now. Now what is the expressions? We have derived already. Bar x equal to A1, sum of A1, X1, A2, X2, A3, X3 over sum of areas A1, A2, A3. Now A1 substitute here and X1 75. Always understand this X1 represents X1, X2, X3 are horizontal distances of a particular section's centroidal distance from particular sections to reference axis, vertical axis. Okay. Similarly, Y1, Y2, Y3 are the vertical centroidal distances of individual sections to horizontal axis, reference axis. Now reference axis. Now bar x, if you substitute here, that is 71.1 millimeters bar x. Now bar y. What is the bar y is? A1 y1, sum of A1 y1, A2 y2, A3 y3 by the sum of areas A1, A2, A3. That is A1. The A1, what is the A1 is 5000 square millimeters. Y1 is, go back here, the Y1 is 25 millimeters. Y2 is 25 millimeters. Y1 25, Y2 25. What about Y3? That is 66.7 millimeters. Substitute Y3 66.7 millimeters. What about A1, A2, A3? A1 is 5000 A2 is 982. Yes, A2 is 982. This is A1 and here it is A2 and finally here it is A3. Okay, and these are Y1 and here it is Y2 and it is Y3. Y1, Y2, Y3. Substitute here A1, A2, A3, Y1, Y2, Y3 and the sum of A1, A2, A3. And finally we get it, the value of 32.2 millimeters, that is bar Y. Okay, bar Y we got 32.2 millimeters. Now let us, yes, these are, alright. What about bar X and bar Y? Bar Y we got it as from the distance. These are the vertical, these are the reference axis, these are reference axis horizontal. Okay. Now what about bar Y? Bar Y the vertical distance, that is 32.2 millimeters. We don't know vertical distance, 32.2 millimeters. That is 32.2 millimeters. This is above 50 mm, above 20 off of the distance. Okay, this is the centroidal axis. Now what about bar X? The bar X is 71.1 millimeters. Here it is 25, it is 50. 71.1 millimeter. Yes, 71.1 millimeter. This is 75. That means below this. Approximately here it is. Bar X and the bar Y. Bar Y. Yes. Okay. Yes. Bar Y we got it wrong. Here it is, right. The location is. What is the bar X here? We got it. Bar Y is the vertical distance, 32.2. Correct. Yes, 32.2. This is bar Y distance. That is 32.2 millimeters. The bar X distance is 71.1 millimeters. 71. Yes. This is bar X. That equal to 71.1 millimeters. Now, this is the centroidal. The centroid, point of centroid of this geometry, the composite geometry of semicircle, rectangle and a triangle. Now this is the geometry, this centroid, the point of centroid is on the plane of geometry. Now understand? But here the thing is that it is neither symmetrical about horizontal and vertical axis. It is unsymmetrical geometry. But in this case the point of centroid is occurred on the geometry. Okay, whereas for L section is the unique one. For this the location is what is the centroid? We got it is outside the geometry obtained. This is the geometry for this location of this L section. Okay, now understand the conclusion about the centroid by observing the calculations. The centroid, the point of centroid can be on the plane of geometry and outside the plane of the geometry. The sections can be a single line of say or can be a what? Can be unsymmetrical sections. The planes can be unsymmetrical sections. Unsymmetrical both the two lines unsymmetry, two lines of unsymmetry. That means it can be on the plane of geometry or outside the plane of geometry. Okay. So with this we have covered in this section how we solve the problems of unsymmetrical sections. Okay, let us, so far we covered by taking the concepts since around 3 sessions. What is the centroid, what is the center of gravity, what is the center of mass, and how to look at the centroid of the plane figures and simple figures and composite figures and single lines of symmetry and also asymmetrical sections or unsymmetrical sections. We have studied and calculated and observed that the location of the centroid not necessary on the geometry. It can also be the point of centroid can also be outside the plane of geometry is observed through calculations. Okay, thank you for this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.